Okay, so we've got a question here. We want to find the infinite solutions of this cubic. We've got 2x cubed plus 3x squared minus 8x is congruent with minus 2 modulus 7. Now, how am I going to factor this cubic? Or is there any other way we can find? We've got a 2, a 3 and an 8, so there's nothing in common there. These are all not working for me at all. So what about if I just factor the first bit? Let's just see where that can take us. So I've got x cubed, x squared, 2 and 3 are co-prime, so I can just take the x squared out. Let's try that. So now I've got x squared and then 2x plus 3. Okay, and then I've got minus 8x is congruent with minus 2 mod 7. Right, so if I've got 2x plus 3 here and an x squared here, factoring by grouping is probably going to be my only option. So if I bring this minus 2 over to the other side, I'm going to have minus 8x plus 2. Now that's not going to work for me because I need something that yields something like 2x plus 3. So if I take out 2x plus 3, I've got to multiply that by minus 4. That's going to give me minus 12. So that's not going to work. But looking at that, if I have a minus 12 here, so I need a minus 12, that's what I need, that's my goal. I've got minus 2 there. Now is there something I can do with that to make that into a positive 12? Well, modulus 7, we've definitely got a chance. So let's take this calculation off the board and try and get this into a 12 on the other side. So minus 2, we need a number, hopefully 12, is congruent mod 7. If that's the case, then all is good. Well, 12 minus minus 2 is 14, so I know that this congruence is good. So I'm not going to affect any equation here at all, or the values of my x, if I turn this into a 12, because minus 2 is congruent with 12 mod 7. So let's change that and leave my factor here. So x squared times 2x plus 3 minus 8x is congruent with 12 mod 7. Now I've got my setup here to get my factor pairs working here. So my group in here, I've got 2x plus 3. So another factor here of 2x plus 3. If I bring this back to this side, it's going to work. So let's set that up. X squared times 2x plus 3. So that's all come from that. And now minus 8x minus 12. And that's congruent now with 0 mod 7. Okay, so now my factor pair, now I can take out a 2x plus 3 from here. So let's try that. 2x plus 3. If I get this bit here sorted, then we're well on the way to try and find our infinite solutions to this cubic polynomial. Well, to get 2x plus 3, if I take out the minus 4, that's going to work. Minus 4 times 2x is minus 8x. Minus 4 times plus 3 is minus 12. So now I've got my pairs here of 2x plus 3. So let's rewrite this now as x squared, 2x plus 3, and then minus 4 times 2x plus 3. So I can rewrite this now with my x squared and my minus 4. I can write this as x squared minus 4 and distribute that with 2x plus 3. And that's going to be congruent with 0 mod 7. So with modulus arithmetic, I've now turned this into a grouping factorising situation, which has been really helpful. So now I just need to solve this for 0 mod 7. Now x squared minus 4, I could factor that out now, or I could just leave that as x squared minus 4 is congruent with 0 mod 7. Either way works. So if I wanted to, I could write x minus 2, x plus 2, let's write that in there like that, and then 2x plus 3, and that's congruent with 0 mod 7. So either of these are going to work. I'm not going to use this one for now. You could use that if you wanted, but this is where I'm going to find my solutions, modulus 7. So for all of these to be congruent with 0 mod 7, basically my 2x plus 3 must be congruent with 0 mod 7, and my x squared minus 4 must be congruent with 0 mod 7. So let's go into that. So x squared minus 4 is congruent with 0 mod 7. Okay, well I can bring my 4 onto this side. So x squared is now congruent with 4 mod 7. I know 4, I can take a square root of that, that's fine. So now x is congruent with plus or minus 2 mod 7. So that's going to give me two solutions of x is congruent with 2 mod 7, or x is congruent with, well, minus 2 is congruent with 5. So if I write that up here to show my working, minus 2 is congruent with 5 mod 7, so x is congruent with 5 mod 7 will work for this part. So that takes care of my first group. Now 2x plus 3, that's a little bit more straightforward. So 2x plus 3 is congruent with 0 mod 7. Bring my 3 onto this side. 2x is congruent with minus 3 mod 7. Now I need to add something on here so as I can divide by 2. Well, if I just add 7, so I've got minus 3 is congruent with 4 mod 7. That's something I can then divide by 2. So 2x is congruent with 4 mod 7. So therefore, for here, my x is congruent with 2 mod 7. And that would take care of this part of the grouping. Okay, so I can write out my solutions. Use my 2 mod 7, so I can say x equals 2, and to be infinite solutions I could just add 7n. So if I add 7n, where n is an integer, and then for this one I just let x equal 5 plus 7n, where n is also an integer. So here I could have 2, 9, 16, 23. This cubic congruence will work. And here I could have 5, 12, 19, 26 and so on. And this congruence is still going to work. So that is my infinite solutions with n being an integer. Okay.